Welcome to IT Fundamentals Training Series, Episode 17. We're coming to the end of Chapter 1, and today, as hot as it is outside, we're going to learn how to cool down. Let's get rolling. Welcome to the IT Fundamentals Chapter 1, Episode 17, and today we're going to talk about cooling systems. And this was recorded in the summer of 2023, so you may be listening to it at a later time. But let me tell you, this summer has been an exceptionally hot summer. And so today's topic is very timely for when it was recorded. Let's hope that you're not in the middle of the winter and you need heating rather than cooling, because today's topic is cooling. So let's get started. So we're on pages 52 and following inside of our IT fundamentals book here. We're looking at page 52, 53, 54, and 55. And we're talking about cooling of systems. Now, I just want to give you an overview of cooling and why it's important. As a lot of you know, I work as a chief information security officer in a data center. And when you walk into a properly maintained computer room, and especially a data center, you're going to find it a very chilly space. But what's interesting is that cooling can be done in a lot of different ways. And for a lot of different purposes. And that's kind of what I want to go over in this chapter, or this conversation leading up to what do we need to address inside the chapter for the computers that we deal with specifically. So let's talk about cooling. So when you have a properly maintained computer room, the temperature within that room will be somewhere in between 55 and 70 degrees, possibly 75. A lot of companies are moving towards that higher end range of 65 to 75, even as high as 80, for purposes of maintaining environmental propriety, if you will, with a lot of the new environmental regulations and things that are out there. It takes a lot of power to use air conditioning. And a lot of people don't understand the real purpose behind air conditioning. It's not just to make the room cooler, but it actually removes humidity from the room, which also impacts the computers as well. So let's talk about that a little bit. So humidity inside of a room, when you have that water, essentially is what humidity is inside the room, that can cause corrosion on the computing systems. And when you have proper cooling occurring inside the room, you have very cool air. And a lot of times in properly maintained data centers, you have what's called a cold aisle and a hot aisle. What you would have is the air conditioning coming up from underneath a raised floor, being pumped up through one aisle, where all the servers are having their faces pointing towards the cold aisle. Because what will happen is those servers will have fans in them that sucks that cold air into the computer. The cold air passes over the top of the motherboard and over the top of the components, and then is ejected out the back end of the system as hot air. You can have a temperature differential from the front side or the cooling aisle to the hot side or the hot aisle on the back side of anywhere from 10 to 15 degrees in a typical type of environment, just because the air passes over that server or the motherboard and the processors and things that are inside of that server. So as that air passes over, it cannot be dense with humidity, because as it warms up and it heats up, just like a thunderstorm in the summer or in the springtime, you'll get a friction going on between the hot and the cold, which will create static electricity. And we know that additional electricity across a motherboard, across an electronic component, could cause additional electrical damage from arcing and sparking. Now, that is a far-fetched possibility, but it could happen, which is one of the reasons why when we go into data centers, we also have anti-static mats, and our raised flooring is made with anti-static capabilities. So back to the cooling piece, that air, that colder air passes over and therefore warms up, and the hot air is exhausted back the outside. But what is also going on there is the hot air is being sucked up into the ceiling in the above tiles. So if you were to walk into one of the data centers where I work primarily, what you will find is that there would be a temperature of, let's say we want the temperature in the room, the ambient temperature, if you will, to be about 70 degrees. Your temperature under the floor, contained under the floor, will be closer to 55 or 60 degrees. Then it will rise up through the cold aisle, get sucked into the computer, get warmed up in there, and then out the back of the server, and then sucked up into the overhead containment area above the ceiling tiles, where the temperature may be much closer to 75 or 80 degrees in there. Now, when you have cooling problems, your servers will heat up that room dramatically. I've been involved in a situation where all of the what they call the crack or the cray units, the air conditioning units inside of a data center were shut down. And as a result, temperatures in that room, simply because of the servers that were running in that room without cooling, and keep in mind that there were a lot of servers in there, but probably a couple hundred servers in that enclosed space. Those servers were raising the temperature to over 150 degrees. And if you took an infrared device, much as like what the fire department uses to look at doors or look inside of rooms during a fire, some of the devices themselves were running closer to 200 degrees Fahrenheit. Now, again, you want to keep those temperatures down in the actual, ambient temperature in the room, about 65 to 70. Temperatures on the servers themselves somewhere between 70 and 80, and the exhaust temperatures would be 75 to 85 degrees. So you can see how much difference. Now, when the temperatures get hot like that on a computer, there's a couple of things you have to worry about. Obviously, we talked about the static electricity a moment ago, but you also have to worry about literal melting. The cores on the CPUs and GPUs and different devices like that could melt. You also have the solder wire that runs the bus inside on the connection points on the bus on a motherboard or a control board could become pliable and potentially even drift, which could, in a very high temperature situation, they could possibly even melt to the point where they become ineffective. And then, of course, you obviously have to worry about fire as well. When something becomes that hot, it could actually combust on its own, especially when you have electricity going to it. So anyway, you can see the importance of cooling, and you can see the impact that a computer will have. If you take a number of computers, in particular servers, and you put them inside an enclosed room without air conditioning, they will raise the temperature on the room. And this is not a joke towards climate change or global warming or anything like that. It is real. I've seen it in my career. Keeping in mind, I've been doing this for 30 years, so I've seen quite a few things. Or as the farmers commercial would say, I've something along those lines, where we've seen a few things, right? So, all right, let's take a look at cooling as it applies to chapter 1, pages 52 and following. There's a great diagram on 1.36 that kind of describes this whole flow of air going across. What they're wanting to do is the case side, or what says case fan, that is your front end of your computer. And what they're wanting to do is they're wanting air to travel across the motherboard, any expansion cards, by the hard drive, because the hard drive, especially the older spinning disk hard drives, is generating heat. A lot of the SATA drives or SSDs are not generating as much heat. So that's not as big a deal these days as it was at one point, but you definitely want airflow going across the CPU. So what you have is you have a case fan on the right-hand side of that diagram that intakes that pulls the colder air in, and then you have case fans on the backside that are distributing the air by, again, creating a suction inside of the case itself and pulling the air across those spaces. And if you remember from our last conversation about the power supply unit, the PSU, there's also a fan on that is pulling air into the power supply unit, and that's not shown on the diagram here. All right, so we've talked about the cooling systems, the case cooling systems, and the importance of cooling systems in general. Probably the most important thing to keep cool on this entire diagram is your CPU, and that's something you need to make sure you understand for your testing. That is, if your other fans fail, and they do fail, lots of times you'll have failures with the ball bearings, and you'll hear that the ball bearings are contained within the rotary piece of it where it actually spins. You'll hear that by either the fan sticking or perhaps rubbing at that joint space. But if you've got a fan that is inoperable, that is directed towards pulling air across the CPU, that's where you're going to find your biggest problem. So make sure your CPU or your GPU is always properly ventilated and cooled. Now, another thing that you have to worry about with all this fan stuff going on is typically a computer, even a laptop, and we'll talk about the differences between desktops and towers versus laptops here in just a second. But you have to make sure that the units also maintain cleanliness. So sometimes you're going to have to get in there with a micro vacuum or something along those lines to clean the dust off of the fans or off of the intake grills. Now, the differences between the desktop and tower units versus a laptop. Lots of times the laptops have their fans typically either on the sides or on the underneath. And lots of times people will have their laptop sitting on their lap when you're wearing a pair of blue jeans or you're wearing some other form of clothing, and that generates lint, and that gets sucked up into your laptop and could cause overheating and fires. I have literally seen that happen where a laptop has caught fire sitting on someone's lap. So don't discount that possibility and go towards that, micro vacuum, cleaning that up and maintaining cleanliness on that. And which is why, a lot of folks try and say, hey, use your laptops on a desktop or on some sort of, if you're going to use them on your lap, use them with some sort of a plastic tabletop or laptop type of piece there where you can put the actual computer itself. Now, desktops and tower units, lots of times, these are placed on the floor. They're placed out of the way where you aren't taking a look at it frequently. You need to take a look at those probably about every quarter or every 6 months to make sure that the intake and the exhaust fans are clean and that there's no lint and dust inside of the computer case itself, because this can cause fires as well. So if you get intake of lint or dust coming off of the carpeted floor, perhaps pet dander is another one, or pet fur is another one that happens a lot inside of a person's home with their desktops, that you'll get that come in, and then as it's sucked in by the fan, you have high pressure coming in, sucking that in, but then the pressure diminishes as it gets farther in, and sometimes will fall down onto that motherboard or that CPU or GPU. And I've seen the end results where that kind of thing has caused a fire as well. And let me also say that if you are a smoker, I have cleaned some computers, and I have seen some computers that are uncleanable, being inside an environment where smoking, or perhaps an industrial environment where shavings from metal product or perhaps even exhaust from different types of machinery has gotten into the computers, and it will lay down on top of the motherboard. And, especially with smoking, for example, it will create a tar layer on top of the motherboard. And by the time someone is called in to correct that, if proper maintenance isn't occurring, it is too late, because the computer is probably dead. It's probably causing some problems. And you look at that and it's like, there is no way to clean this. You cannot rub water across that. You just can't clean it in that manner. And it becomes a point there where you just have to replace it. So anyway, that is cooling for us today. The last thing I want to talk about is something is called liquid cooling. Oh, and let me take a step back. We've already talked about heat sinks. So that is an important piece in this chapter that I'm not going to go back over, other than to say the purpose of heat sink is to draw the heat off of something like a CPU. If you want to talk more about heat sinks, go back to our episode on processors. But what that heat sink does is it draws the heat off of that into like these vertical chambers inside that heat sink, and then the air flows through that and pulls that heat away. And so that's an important piece there, but we've talked about that extensively previously. I don't think we need to go into more of it here, but I do want to talk about liquid cooling because it's becoming popular and trendy, and I use those two terms very deliberately. So let's talk about the trendy side. A lot of gaming computers, a lot of computers that you'll see, a lot of towers that have little fancy lights and stuff in them that they're selling at places like Best Buy and other computer stores have an option for a liquid cooling type of scenario. And sometimes this is glycol, sometimes it's another form of liquid that is and should be self-contained in the unit. Now, the obvious concern there is if you get a leak, that going on to your motherboard or your CPU, GPU, that will completely ruin your system. But they're not crazy. They're not selling these things that are going to leak on an average basis. What you have to worry about is if you knock over the tower before you start using it again, make sure you don't have a leak in there. Now, the other place that's the trendy side of things, and liquid cooling is very effective because it's taking the heat and it's moving it through a fan-based system, much like a geothermal system would work inside of a building, inside of a home, where it's transferring the heat. Even the way it works inside of your radiator in a car, it takes the heat out of the highest heat capacitors and moves it to another location to cool it down and then recycles it through. Water and liquid is a very good transmitter of heat, and also, so the cooling coming in is the water is cooler. It allows for cooling there and then pulls the heat out of the environment as well. But the other place where liquid cooling is being used quite frequently is in the data center environments. And what we do is we put the doors of the cabinets sometimes on both sides, but typically on the intake side, would have a whole bunch of rods going through there that has a glycol or other type of cooling liquid inside of it. And it works exactly like I described earlier as a radiator in your car. If you want to know what it looks like, obviously it probably looks a little more fancy and less industrial than a radiator in a car, but it's a similar type of concept. There's a reservoir, there is a series of coils where that cooler air, or that cooler water goes through, and then as it extracts the heat from the environment, it passes it through and back through the radiator for more cooling and just continually regenerates that. It does help with power consumption and it helps with other types of environmental pieces that occur inside of a data center. All right. Again, this is cooling. This is the last part of chapter 1. And I look forward to talking to you next time about how to work through these written labs and these exam or review questions. We'll go over some of the review questions in a short episode a little bit later on. Tomorrow we'll release that episode 18. This is episode 17. So again, if you have any questions, you want to reach out to us. I've started putting my contact information here. If you're watching the video along the side, that will allow you to reach out to me either by phone or email. So make sure that you take a look at that. And we definitely want your input. We definitely want your response to how we're doing things here, and if this is of any value to you. So until next time, go out there and cool something.